Hello students, welcome to this lecture and my apologies, I am re-recording first 3 minutes of this lecture because there was some, problem in the audio. So this question is what you see in the black, don't refer the one which is written in blue. Now the question here is we have a LCR circuit with a resistor 4 ohms, L and C, and then we have a EMS supply, AC supply of this is equal to E naught sine 100 pi t plus pi by 6. We are given that V1, the voltage in this ammeter is 40 volts, voltage in this is 40 volts again, and voltage in this is 10 volts. We have to find I0, IRMS, IT, E0, L and C. Okay, now the most important thing here is that if you are having such type of setup, whatever reading you see in the voltmeter is nothing but the RMS value. Let me summarize it. If you connect a voltmeter in such a LCR circuit, across L, C and R, then the voltmeter will catch the RMS value. Okay, so we know that VRMS across resistor is 40 volts given to us. Across resistor is equal to 40 volts, but again we know V is equal to IR, so VRMS is equal to IRMS into R. Okay, now just substituting the values, I can say RMS is given to us 40, VRMS is given to us across resistor, we have put in 40. 40 is equal to IRMS into 4. So IRMS is equal to 10 amperes. Also, we know that the IRMS is equal to I0 by root 2. Substituting the values, I can say I0 is equal to root 2 into IRMS, which is root 2 into 10 ampere. So, out of this question, we have already done I0, which is root 2 into 10 amperes, and IRMS, which is 10 amperes. Okay, so this is just first two sub parts of this question. Now let's proceed to the other sections. This is done and this is done. Okay, next comes IT. So now the students, as I said, we have to find IT, and for IT we need to have phase as well, correct? Okay, now remember and go back to what I said earlier. So in the phase diagram, V naught can be replaced by VR. So what I mean to say is, in the phase diagram, either you can use peak voltages or RMS voltages. If you use the peak voltages, the result would be the peak. Okay, if you use the RMS voltages, the result would be RMS. Okay, now having said that, let me draw the figure. Now, this, and this is VL RMS now. Okay, and this is VR. Okay, and this is VC RMS. Correct? So we have drawn the RMSs this side. Now, go back and see this. Check it out. So the voltage here is 40 volts. V2 is 40 volts. And this is again 10 volts. So the overall, this is a inductive resistance is more, and that is why we will have the figure something like this. This is for because it shows, because capacitance XC is less, XL is more, so the whole circuit is more of inductive. It is a inductive, it has inductive reactance more. Okay, and that is why we have drawn this figure wherein the current lags, voltage leads. Okay, now in this case, this is XL minus XC. So, or this will be VL minus VC. Okay, so here from here I can say tan phi is equal to VL minus VC by VR. Okay, or I can say tan phi is equal to 30 by 40 is equal to 3 by 4 and 10, and I will say phi is equal to 37 degree. Okay, so that makes sense. Hence I can say, let me write it here and utilize the space. IT is equal to I naught sine 100 pi t plus pi by 6 minus 5, or I can say 10 root 2 sine 100 pi t plus 30 minus 37, which is equal to, if I have to write, let me utilize the space. This is the equation of current. If I have to write it here, then I can write it right. I is equal to 10 root 2 sine 100 pi t 100 pi t minus 7. Okay. So in the previous question, and now we are left with E naught, L and C, which we have to find it out. So which I have noted it down. I've changed the sheet because there was no space there. Okay. Now we know that what? We know that VRMS whole square is equal to VR square plus VL minus VC square. From where? From the diagram which we have drawn, the phasor diagram. We know this is VRMS, and this is phi, and this is VR, and this is VL minus VC. Okay, so if I just put in the values here, we can get VR square is nothing but 40, which is given to us. So if I take under root both sides, this becomes 30 square, or I can say VRMS is equal to 50. Okay, but on the other hand, we also know that VRMS is equal to V naught by root 2. Okay, so just put in here and we have we can get V naught is equal to 50 root 2 volts. Now the last portion is L and C. Now this is very simple because we have been given 40 volts L and C. So let me write it here with a different pen. So L and C, we have been given we have been given 40 volt for 40 volt across L. So we not VRMS across L is equal to IRMS into XL. Correct? Now I can just put in the values. 40 is equal to 100 pi in, into XL. What is XL? XL is nothing, omega L. 100 pi into, let me first, into 10 L. Okay, or from here I can find L is equal to 4 by 100 pi, which is 1 by 25 pi Henry. Okay, very good. So now finally we are arriving to the last one. Let me use another color for this. Same thing. We know that, let me utilize this space. I know that VRMS across C is equal to IRMS into XC. So 10 is equal to 10 into 1 by omega C, because we know XC is 1 by omega C. So we can find C is equal to 1 by 100 pi farads. Okay, so this solves this question, and with this we are closing this lecture. We will continue in the next lecture.